So hello everyone, welcome back to the channel. So in this video we are going to solve the first round of weekly contest 296, that is min max game. So it is of easy difficulty level and many coders were able to solve this problem during the contest. So I hope that you have read the problem statement. So let's quickly jump to the example to form an approach and to understand the problem more clearly. So in the input we have given a nums array and it is of length 8, and what we have to do with the input array. If the length of the input array is equal to 1, that means we just have to turn that element. Otherwise, we just have to form a new array that will have size equal to n by 2. So as we have 8 elements here in this array, that means we have to create a new array that will have a size n by 2, that is 4. And with the new array, for every index I, that is even. So suppose here the index is 0 for the new array. What we have to do is we have to assign it the minimum element between these two elements, that is 1 and 3. So the minimum element is 1, so that's why we have assigned it 1. And for the odd index, what we have to do is we have to calculate the max between these two elements, that is 2i and 2i plus 1 for that index I. So here the index is 1. We have to calculate the maximum between 2 and 2 into 1 plus 1, that is second and third index. So at the second index 5 is there and at the third index 2 is there. So that's why so maximum between these two is 5. Similarly, we have to repeat this process, and once we have done, we have to replace the new nums as the original nums. So we have to replace this new array with the original array. And once the size of this array comes to 1, that is only one element is left in the array, we just have to return that element. So this is how the algorithm is working. So this seems to be a simple recursion problem. Why? Because at every stage we are breaking this problem into smaller problems, and once this smaller problem is small enough to be solved trivially, we just are returning from there. That means that we are arrived at our base case. So let's try to implement our approach step by step and see how it goes. So let's first try to write the base case. So the base case was, if the size of the nums is 1, we just have to return the element that is at index 0. So for that we will write the condition this, and we will just return element at index 0. That's it. After that, it stated we have to create a new array that will have the size equal to n by 2. So we will create a new vector v that will have a size half of the original array, and it will be initialized to 0. And now we have to fill this vector v. So it is given that for every even index we have to do this, and for every odd index we have to do this. So we will simply traverse in a for loop and write this condition. So our for loop will run for nums dot size by 2, that is the size of the vector v. And what we have to do in this, we will check if the index is even. So we will take the modulo with 2, and if it is even, we will write this condition, that is we calculate the minimum between the index 2i and 2i plus 1 of the original array. Else we will face the odd index. So for odd index we will write this condition, that is maximum between the element 2i and 2i plus 1. So once we have completed this for loop, we just have to return min-max game, where the argument we will pass is v, that is the new array. So once the size of nums reaches to 1, it will just return the index 0 element. So that is how this problem can be solved. So let's try to run it and see what it results. So it's matching the expected output. Let's try to submit it. So it got accepted. So this is how this problem can be solved easily. So I hope that this approach is clear to you, and the time complexity of this solution will be log of n, as we are dividing this problem into smaller subproblem at every stage. So in case if you have any doubt or any query, you can comment it down. I will be more than happy to solve it. So let's meet in new video with a different problem. Till then, happily coding.